with this community. I love to be part of different communities. That's why whenever Abdul Karim actually approached me, I said definitely I want to be part of different communities, including this community. So I just wanted to first show you about, at least so that you can see me. And actually, uh, uh, first of all, I wanted to tell that we are the first in this Saudi Arabia, where we started our cybersecurity program, Bachelor in Cybersecurity and Digital Forensics in 2015. At that time, even National Cybersecurity Authority in Saudi Arabia was not born. It was born in 2017. Now, that's why everywhere you will go in Saudi Arabia, you will see our students. And currently, we have more than 800 students in my department, where I'm heading this department. And we got the NCA, we're the first to have the full NCA accredited. Also, we recently got the full ABET accreditation. This is a part of the story where I'm coming from. Now, today I will be presenting AI for cybersecurity and security of AI. As I said, I'm a full professor in cybersecurity. I will first give a brief overview, some of the key challenges. And while AI for cybersecurity is too big, I will be picking up only the industrial control system security or OT security as the case study, that how AI can solve the existing constraints, existing bottlenecks, existing issues with in the industrial control system domain. I will then show you, because you are enthusiasts about how to design AI for different. So I will show you how we design, because we have been building different systems for our own self, for our own labs, for different industrial purposes as well. So I will show you how we design so for example, how we design a SOC. You as a cybersecurity specialist, you know what is SOC. So I will show you how we design a AI-based SOC. And then our next part is how we can secure the AI. So instead of regular AI, I will take an example, which is the recent how we use a multi-agentic system, which is very hype at the time. So I will show you how we can, I will show you how vulnerable they are, and in fact, how we can secure it. Finally, we have been building these multi-agentic system quite some time, almost one year and a half. So I'll share with you some of the lessons that we learned. So as an overview, the reason that why we need AI, that's why I will give overview that one of the reasons is IT and OT domain has converged. It was an isolation, but now a lot of automation is happening, and almost everything is now digitalized. That also includes our manufacturing industry. I just told you that I will taking an example from the industrial security perspective, that our IT and OT, so we can remotely observe the different production system, different telemetry data, different value addition, right? So we can see different assets, their operations remotely. This is an example where I'm a 6G security researcher. I have been working on 6G for quite some time. This is an example, our oil and shipment as an example, that we use heavily, for example, 5G, 6G, whatever you say. I'm just giving an example that how much different technology has brought things together within fractions of milliseconds, 0.1 millisecond. Data from oil and shipping, for example, domain all the way to the headquarter, and again come back to the ships in just fractions of milliseconds. How faster we are now. This connectivity actually has brought lot of risks, okay, in the specifically one in this case in the industrial domain, industrial control system security. That this connectivity, although we are bringing efficiency, but that is bringing a lot of risks from cybersecurity perspective because they're connected. As a result, daily, almost every organization that is average is facing a lot of attacks. For example, 7 million uh, data records compromised every day. So it's a just because we're connected. This is a sample set of attacks as an example uh, that we face on a daily basis. Those of you who are working on different SOC or SIEM solutions, I'm sure you are facing this type of breaching that are being used by the cybersecurity specialist or SOC specialist, SOC L1, L2, L3 team. Now, what are the challenges of to us basically? The first challenge is that our hidden industrial systems or whatever assets that we were supposed to protect are no longer protected. That's the first challenge because there's nothing that is basically completely hidden from attackers. Every layer of the, whether it's the network layer, endpoint, doesn't matter, everywhere there are basically there are vulnerabilities and there are threats. This is and one of the reasons, as I say, that this IT and OT network, they're converged. And this is some sample example of why different challenges are there, of critical national infrastructures like manufacturing, oil and gas, pharmaceuticals, transportation, you just name it. On the average, we have studied more than 55 different industries in Saudi Arabia, as an example. And we have, for example, studied their different vulnerabilities. I will not go into details, go into different MITRE TTPs, go into different, you will see the vertical, industry vertical based cyber threats on different industries. But there are many reasons why this. We will not go into that one. Our target is to see how AI can support. So we are using different kind of protocols. We're using different types of OT assets, right, that we have to secure. Another challenge is another challenge. By the way, average vendor, average organization, like for example Aramco, they have more than 55,000 vendors. So think about that all these different vendors have their own different types of hardware. They have different patch management. It's a very large attack surface, I could say. On top of it, here you go. We have now, every day we're facing another challenge that came, and the new kid in the next door, which is the AI. Now using AI, even as someone can create a very super viruses with very limited knowledge. Almost you don't have to be a lot of certified in malware specialist. Just using AI, you can build a very sophisticated malware. The issue is that industries, they do not really patch that fast. Patching goes maybe in 2 years, in 5 years, even 10 years. So many industries are like that. So this AI-based advancement, attack rate is so fast than the patching itself. That comes into another challenge, which is abuses of AI that's happening every now and then, generated malware, new types, polymorphic, and then so many different types of AI is bringing havoc on different types of empowering. AI in the wrong hands is giving a huge challenge to the cybersecurity community. Now, this is one of our research that says, for example, we have studied, for example, 680 attack softwares, 130 actors, 400 attack groups, 191 attack techniques. 385 attack sub-techniques. So you see that uh, there are there are so many uh, attack types, innovation in attack are happening that will require new and sophisticated type of defense mechanisms, I would say, to the cybersecurity community. This is really, really challenging our cybersecurity community. Our red teamers, our blue teamers, they will be challenged with this innovative type of attacks. Those of you who are doing R&D, because we do a lot of R&D, we are working with different CTI platforms to just figure out what are the everyday new types of attack vectors or MITRE TTPs are being discovered. Now, in order to handle this situation, actually, we are looking for AI-based cyber defense. That's the overview of what we brought into this. Now, in order to defend the new generation of attackers, basically, we need an advanced level of AI-based solution. This is an example of, this is one of my students. They have actually applied this. This is one of my students about 2 years before they graduated, my capstone group, that we have this cyber range where we could emulate more than 200 VMs of different complete IT/OT network. And then we have the SIEM or SOC solution. We have the CTI platform. We have the digital DFIR platform. We had different type of automation process automatically, basically looking at, and then we added within it our I'll share with you. We started basically building our AI assisted cyber range. This is one of the solutions that we have. We had been working. This is one of my groups that work, actually now 3 groups now. And so we have added our AI components from machine learning to deep learning to generative AI, all different types of. Now, if you are not sure about, I would just wanted to tell you, you have to have capability of both machine learning, deep learning, and the generate. All 3 families will be needed. Machine learning will be needed for a lot of predictive things. Then you will need deep learning models, for example, if you have some vulnerable for APKs or, for example, PE files or a lot of log files, or doesn't matter what type, then converting those vulnerable VMs or vulnerable attachment like phishing attachment, you can convert that into a binary file, a DLL, for example. If you have a DLL file that is dropped by the malicious actor, or if you have a phishing, for example, a file that came from an email attachment, you can convert them into a binary file, and that can be converted then into an image file, and that image can be used for a deep learning like CNN or other architectures. I will not go into more details, but if you're more interested, definitely pass by. I love spreading knowledge, don't worry. But we have been doing a lot of research on deep learning models where the accuracy of deep learning models are more, for example, malware analysis. We have been building a lot of sandboxes where, you can throw your phishing attachments, and then our sandbox can actually immediately tell you, convert that into a binary image, and then add our CNN models, ensemble models, and then tell you exactly this is what type of, it's Shamron virus. This is, for example, Revil malware. It is APT29. We have been doing a lot of these R&D for, but nevertheless, this is a AI assisted. We can add AI within our different types of AI. I will show you some of the running demonstration now. This is an example. This is a real life picture that I have taken from my cyber range, where this is a real asset as an example. And if an attacker can inject some malicious, for example, malicious command to stop the sensor for example, level sensor. but then we can train our AI algorithm that can actually keep monitoring your network, keep monitoring your firewalls, keep monitoring your different telemetry data, you can say, of you coming from different assets, and then the AI can automatically come in as a co-pilot if you train well, and it can basically help you to safeguard very critical infrastructure from huge loss of human lives. An example. If you have a very I would say, designed, if a very well-designed, I would say, cyber range, then human and AI can talk to each other. AI can provide evidence. This is an example. SOC analyst, if there is an attack on your assets, whether IT asset, OT asset, firewall, endpoint, doesn't matter. It is your call. How do you design? What kind of knowledge you have given? It all depends on what type of AI you have been using. You have been using, as I said, machine learning models, deep learning models, generative AI model. And these are all, by the way, all of these examples are coming from our own students or myself or our research or our publication where human and AI can talk to each other. And AI can the provide the evidences and understand human language. It's a fantastic world that we're living now, where you have an AI as an virtual analyst. Just you need to understand. It's an example that uh, if there is something that is detected, it can be passed to the SOC analyst. SOC analyst can start talking, asking for more evidence to make sure that this is a credible intel, just like you have your CTI platform that gives you the quality of your intel so that you can trust so it is all visual based. Yes, there is an evidence that there is a malware that has disrupted one of the operations, but then it can ask for more questions and it can give answer using different. So this is the stack of the range that basically we have been using for our AI. Now, as an example, I will show you now how we can design a SOC. I'll be very quick with the existing SOC that we have for our OT SOC, you can say. It is very massive volume novel attack surfaces are available beyond human capability to go into the DFIR process. And then we have so many Windows XP, we have so many legacy systems that even our SOC team will be very tired of. And on top of it, very few human resources are available. There's a shortage of OT. That's where our AI again come into play. Why we talk about AI for cybersecurity? The reason is that our AI can process unstructured logs, auth log. It can go into your FIM. It can look at your firewall traffic. It can look at your next generation firewall data at layer 7, layer 4, layer, you just name it. So all these different unstructured data, different anomaly, you can train it to what is baseline, what is attack, what is an APT 29, APT 30, or this is what type. You can basically train it the way you want. It is your AI capability that is the only limit of your sky. And then generating reports, I will shortly show you some of the sample implementation about how we design and OT SOC using AI. First of all, what are the challenges that you will face that you might not have enough data set to design an OT specific AI models so you need to be clever enough how to handle this one. And then also you will need a lot of real time because your OT system requires, safety instrumented systems. It monitors very sensitive, it's very critical national infrastructures. It has to be real time. So any attack that's happening, you cannot take like your IT, okay, an alert has been generated, then your SOC team will get, SOC L1 will do initial triage, then you go to SOC L2, then L3, then proper isolation, finding root cause, and then after 2 days, if you have this OT field, then you cannot really you have to do an real-time handling, right? Because safety and reliability, human life, and it's a massive loss. And that's why at the same time, we are saying that explainability, it's your AI is to be explainable, is to be a lot of like safety, auditable, explainable, secure, privacy, fairness, all you have to build your AI capability so that human and AI can work together. Now, how do you handle it? I will quickly, because of short time at hand, how do we build our OT software? First of all, as I said, you need machine learning, deep learning, computer vision, natural language processing, everything that you need. And this is the first capability that that you need almost everything, including the Gen AI. The second thing that since I'm showing you a design of an IT OT converged network. So for example, you have your IT zone, you have your OT zone. You have to decide what is your target, what's the scope, because you need to train your AI model based on the data of your organization. Then what we do, we look at our organization that we want to safeguard. Depending, for example, your organization name is XYZ. You need to understand their assets. What are the different networks? What are the different subnets? What are the different segmentations? All these. And then, for example, different network architecture of your IT and your DMZ, everything your AI, you want your AI to learn. And then what we do, basically, we look at our different zones and we create our own VMs. I will not go into too details, but if anyone interested, we can discuss about it. But this is how we look at different organizational architecture, and then we bring them into IT/OT converged network, bring them into assets, and virtualize them within our cyber range. We generate our traffic, and then, as I said, there are specific way that you can build your AI model specific to your OT industry or IT/OT converge. These are different tools that we have been using, and different scenarios, IR and incident response and SOC exercises like the blue teaming, purple teaming exercise, ethical hacking exercises, MITRE, IT/OT attack and defense exercises, table exercises, and we provision our VMs using different Ansible, Docker, Vagrant, all different tools that you need to be able to handle, to be able to emulate your network traffic, your EDRs, your endpoints, and stuff like that. The next thing that we need is from your your virtualized network, you need to develop your data set, private data set. Now we need to generate configuration data set, asset data set, GRC data set, policy data set, CTI, EDI data set, just you name it. It depends how granular level you want to go. At the end of the day, you have to develop your own data set, because really no organization can share their data with another organization in India or in Pakistan or in somewhere else, because your organization data has to be very secure. That's why your team, your cybersecurity team should have their own AI team, so that you understand that that your data is not crossing the boundary, not going outside of your cloud somewhere in another country, because it's a very private data that we're talking about. Next part is to be able to use your foundation model to then give the foundation model to your collected data set, and then either use fine-tuning or RAG process. It is an AI knowledge domain that you need to have within your team. And then we also need to have our GRC capability, so that our network or our AI actually is uh, our cybersecurity management system or in our AI management system. We need to make sure that our AIMS or PIMS or CSMS, all of them are compliant to different standards. Otherwise, if you are using AI for your cybersecurity operations, but it's not either, for example, in Saudi Arabia, we use ECC, CSCC, or OTCC. If we are talking about OT domain, for security, it's 27001, 27002, 27701. If it is OT, then it's I62443. If you're talking controls, then CISB 8. If you're working with Aramco, and so many different types of standards, we then build your AI model, train it very well so that you have your AI system trained to understand different kind of compliances. I will not go into details, but there are processes how you can establish or train your, for example, in this case, OT security AI model, which is we are training with IC62443, and then how we basically deploy our model on our system, and then we do the testing. Once you have a trained AI model, then you and your GRC team can work together for your GRC system development, implementation, to auditing, all the way to continuous monitoring. Everywhere you can use your AI and human can work together. We have been working. This is a no, this is that sorry, this is an implementation of our oops. Sorry, what happened? For some reason, it is not, the video is not running. It is running our AI for developed for our OT SOC. For some reason, it is not. Oh, here you go. Oops, what is this? It is not working. Something is happening. No, it is not working. For some reason, I'm so sorry. I thought I will show you how our GenAI model is working. It's trained on different ISO, more than 200 different GRC operations, standards, end-to-end operations. But anyway, let's move forward. Now, this is what I wanted to share with you, that how AI can help us in, say in the previous case, our human AI, because the AI has been trained to be a GRC specialist. Now you can ask about, hey, I want to apply ISO 27002. Can you help me with how do we create a cryptographic policy? My industry is a critical banking industry. I need to have a fintech or Fin6, for example, is our attacker type. I need to make sure that our, for example, so our SAMA, Saudi Monetary Agency, we want to be complying with our cryptographic algorithm that, for example, that is compliant to Saudi Monetary Agency's, compliance. So our AI model can generate the cryptographic algorithm that will be needed for a financial industry, as an example. It's a fantastic world where you just need. Now the second question comes is how do we secure? Why we need to secure? That's the question. So I will give you an example from a multi-agentic system perspective, as an example, because this is very hot topic. So we'll show you how we do that. Now, agentic AI is this figure shows that different types of AI generation that we have been witnessing. RAG, for example, you see that this is the 2003 and 2004, so the RAG is still rising, and the prompt engineering is not really going, because we don't really need that much. But agentic approach, see, it is heavy on demand. Fine tuning, because very expensive. It requires a lot of GPUs. Reinforcement learning, it requires again. So just RAG is so easy, and it brings a lot of quality, a lot of a problem can be solved. That's why. But you see, the agentic approach is rising. Why? Just the reason is a user request can be handled by an agent. An agent can use other tools. It can use memory. It can do planning for you, and then then your agents can basically do planning for you, take actions, talk to human, take data within the loop, run some codes. You can call other devices. So And then you can also call your AI models. So that's where it's a single agent approach. And so they can also use memory, see long-term memory. I mean, your RAM, your disk. It can use your vector databases. Uh, agents can do things for your SOC operations. But now, if you have multiple agents, as an example, then basically one agent can work with another agent. Fantastic world where you can what agents can basically call APIs. It can go to the website. It can go to the databases, and one agent can talk to another agent, and then share tasks, and then combine the tasks. Fantastic. For example, even you can call APIs using MCP protocols as an example. It's a very nice opportunity for cybersecurity of a team to basically handle the huge problem that we are facing in terms of shortness in terms of experts of level 3 SOC analyst or the CTI specialists like that. It's an example how multiple agents can help in. Some agents can help in triaging. Some agents can help in, for example, threat intel. Some agent can help in EDR, looking at EDR or infra remediation, security controls, detection engineering. So the agents can divide the tasks and then complete the task of your whole SOC. Now you can have a SOC till we have been working for quite some time, more than one year. We have many running SOC. We have been designing SOC SIEM solutions using multi-agentic approaches. But what's the problem? See, the problem happens, and this is another example how one agent can basically talk to another agent using MCP protocol. They can, they can talk to the database. They can talk to APIs. They can use webhooks. They can. It's a free world. You can do anything you want. But it's another problem project. This is an example where we have been using generative AI to teach the telemetry data of industrial assets. And it knows about the harmless firmware. It can detect that something is not working. What is the different, how to parse the logs. This is running from a real life system, by the way, that an attack has happened. You can interact with it. You can talk your logs. You can see which exactly telemetry data, which sensory data it has is not working, and even you can block it because now using MCP protocol, you can block it, the attacker from the firewall. You can, for example, isolate it. You can do whatever you want because uh, all that you need is to be able to design your MCP server for your organization locally so that your data never goes outside. We have been dealing with this for quite some time, and we are actually enjoying the power of the MCP A2AN multi-agentic system for industrial control system automation and monitoring. That's a fantastic world. Now let's go back to even some more our day-to-day works that we had been doing as a cybersecurity professional. Actually, we can do our either reactive operations, running the playbooks, using our, for example, detection rules, threat hunting, patching. This can be done using automation, using our new generation of our friends, which is the multi-agentic system. Fantastic. Now, what are the risks? See, the risk is one agent is talking to another agent. Now, if one agent is compromised, and if one agent gets compromised or man in the middle, you can inject one of the malicious, then everybody's compromised. Why? Because they're talking to each other. It is their machine-to-machine protocol or agent-to-agent communication is happening. That's why we have been working, or the cybersecurity industry is very active that how this can be handled. For example, you can hack the agents the way you want. Now, you can fool the agents. You can do prompt injection. You can do memory injection. You can compromise their goals and planning. You can, you can just studying this domain. This is a fantastic domain that how you can break down the working, how you can compromise the multi agents using. I will not go into details. Just I want to open your eyes. This is a WASP Mastro threat model. This is free, fantastic, one of the best, and one of the best, I would say, sources that you can really think about at this time. So if this is a multi-agentic system, this is a T means threat. Threat number 10, this is threat number 14, from application domain to the planning domain, to the action domain, to the LLM domain, how one agent and then the human in the loop, how you can poison the memories. Now think about, we are relying on these agents and they can talk to the database. So now they can talk to, they can inquire, they can call an API. Think about how dangerous it is that now they can persist. So a rogue agent can persist in the memory. It can persist in it can bypass your firewalls. It can bypass your, endpoint EDR solution. So, and then there is no accountability. So what is the accountability? Now, we are using this in everywhere, multi-agentic system, healthcare, defense, finance, smart transport, without even understanding that they are so vulnerable. This is one example. I just want to open your eye. Like people, they are running after MCP protocols, but this is coming from, again, from OWASP community. This MCP has servers have been found vulnerable to all crazy types of different attacks. Now, since we as a cybersecurity researcher, we have been, for example, for myself, this is my own personal team, my research, since January 2024, after reading more than 2,000 journals, we found more than 92 different attacks on multi-agentic system. How do you defend? How do you defend this guy? Simple. This typical SecDevOps that we used to have, so traditional multi-agentic system that people are proud of, AI community is very proud of. Don't buy it. Pass it through your requirement analysis, threat modeling, from design, static analysis, dynamic analysis, until the testing and deployment in all the SecDevOps operations. Your agentic multi-agent system have to, in this case, AI, SME, but our example is multi-agentic system. And then make it through ethical hacking, risk assessment process, security auditing. I'm talking about multi-agentic system-based AI systems. Do the pen testing, do red, blue, and purple team exercises, do security and vulnerability scanning. At CTI, do their adversarial TTPs, do a complete privacy impact assessment, because really we have been hacking these models and then reverse engineering. Everything is possible, including, you will not believe, the state of that model came yesterday. We did the vulnerability assessment. It found to be absolutely vulnerable. So in other words, even if you are thinking, oh, hey, we have an amazing, and AI team is thinking, wow, we have a multi-agentic system doing a lot of amazing things, but wait. As soon as do an attack with our cybersecurity expertise, the agentic system completely disrupts the operation. That's why we need a defense mechanism so that your AI model can understand that an attack is happening and it can safeguard itself. And then I will not talk about it, but just giving you, there are so many different there's so many defensive strategies are already there proposed by cybersecurity community. Just as an example, we as cybersecurity specialists, we have been using identity and access management, access control system, authorization system, authentication system. But then how about your multi-agentic system? Because you have dedicated some tasks to talk to the database, calling an API, calling a webhook, and then getting data from multiple systems. But then how do they authenticate themselves? How do one agent make sure that the output from one agent is not going to a malware or man in the middle, or not being abused, or someone is not injecting some So how do you handle it? Answer is use blockchain as an example. So now the blockchain community actually came up with ERC 8004 standard so that a decentralized trust mechanism or identity and access management. In other words, your agents have to be authorized. Your agent's identity have to be authorized through a, so you don't have any PKI, public infrastructure, that will create a, for example, create a certificate, because we use certificate for CA, certified CCA, right? Certificate authority for what? For the trust mechanism. But here for agents, what kind of trust do you have? How each, because you're delegating the task to a, you have a SOC that is using 20 different low-level things, looking at sensitive Nmap scanning, looking all different sensitive things they have been doing. Where the trust? How do you have the what is your DLP solution for your, how do you know that your agents are not leaking? You need really, really to come up with a new generation of your defensive mechanisms. Otherwise, really, anyway, and now you will have to face the real, the real issue. That as cybersecurity specialist, now you have to be also an AI specialist. Not only AI specialist, expert. Example, if you are using AI stack, for example, the WASP Mastro is an agentic defense layer, defensive layer where 7 layers have been proposed, where you can safeguard from foundation model, you can safeguard your data operations, your agentic framework. When you deploy an infrastructure, I will not go into details, but Mastro is a very successful in looking at different threat models, different type of threats that can be posed by your AI models. It's a very fantastic, for example, a fantastic, I would say, work that have been done thanks to the cybersecurity team, those who are working for the security of the AI, so that your AI do not make ourselves unsafe from, because people they have been using it. Again, there are so many different layers of multi-agentic system. You can add a lot of guardrails, I would say, of different types. You can, okay, so you can, there's so many different granularity of your guardrails from your multi-agentic applications, starting from input all the way to output. And then if you want to safeguard your MCP servers, go ahead. There are so many different strategies that is there already for us to just apply it and do for our enterprise, for our organization. Lessons learned. Unfortunately, unless if you are satisfied as a cyber, oh, I have CISSP, I have OSCP, I'm sorry to say this, it's not going to work. You have to upgrade yourself, my dears. You have to, I mean, I'm talking to myself. For example, I upgraded myself with bug bounty hunting. I'm all using AI, all using machine learning, deep learning, and Gen AI, just because the opportunities are there. But that requires self-learning because of the capabilities are there. That requires funding. You need a lot of GPUs. You need a lot of strategy. How you bring AI, because you cannot just use AI and then use some cheap AI thing somewhere in India, and then you are sending your Saudi, one of the companies, what do you call it, managed services, and then sending your data to the AI model that you have trained in a cheap GPU in India or somewhere else or in Canada. It's not going to work. You need to understand